Hi friends, welcome back. Now let's get into our next session. The next session is about the multi-core processors. With the improvement in the VLSI technology, the enhancement in the VLSI technology, the size of the chip started shrinking, and the physical dimension of the chip cannot be reduced as the logical size of the chip was shrinking, because it has to be handled manually or by the even robots also. It should be of some dimension that can be handled, and due to advancement in the VLSI technology, the size of the processor went on shrinking, and this created void in the physical chip inside, and this void could be filled with more number of processors, and this idea gave birth to multi-core processor. A multi-core processor is a single physical CPU chip that contains two or more independent processing units called cores. So this example, we can see that two processors are put on the motherboard. One is processor 0, other is processor 1, and each processor is in turn having two cores. Each core has its own associated L1 cache, and there is L2 cache per processor. So totally in all, each processor chip will contain two cores, two L1 cache memories, one for each core, and one L2 cache. So that way, if our motherboard contains two processor chips, then in all we have 4 cores, 4 L1 cache memories, and 2 L2 cache memories, and that through the motherboard is connected to main memory and other associated system. So why to use multi-core processor? The first thing is power efficiency. So it requires lower power than multiple CPUs. Instead of having one CPU per chip and each chip is consuming power, we can make one chip having multiple cores, and that chip will consume almost same power as a chip containing a single CPU. So that's one advantage. That's power requirement will be very small. Then we can run the task parallelly, so multiple tasks can be run simultaneously because each core can take up one task individually, and then space we can save, and because the improvement in the VLSI technology, the size is shrinking, and because of this, in the available space we can have more number of cores than considering separate chips, one containing each processor. If one chip contains 4 processors, then the overall size required in the motherboard is of one chip instead of size of 4 chips. So that if we just keep looking at that, then these benefits grow multifold one by one, and then we have a better performance scaling than increasing the clock speed. So there was a limit to the clock speed. We went on increasing the clock speed from 3 MHz 8085 processor till went on to 3 GHz, and later we realized that beyond 3 GHz, if we go, the processor started getting heated and lot of problems were arising. The computational problems were arising, the heat dissipation problem was arising, power requirement problems were arising. So we tried to stop increasing the processor speed. Luckily by that time, improvement in the VLSI technology was giving us more space So we could think of adding more cores than increasing the clock speed. So through adding more cores, we used to get a higher performance than what we were doing earlier by increasing the clock speed. Now, how does the operating system works with a multi-core CPUs? So here the operating system sees each core as a separate processor. So it's like CPU 0, CPU 1 and so on. Then uses this multiprocessor scheduling to assign tasks across the cores. Then threads can run simultaneously on different cores. Operating system uses load balancing, process affinity and core specific queues to manage the performance. Now if we think of what a multi-core processor can do, so let's just check up one example. Let's core can work with a single thread or multiple thread. That's how the processor can be designed. So here a single threaded processor core, what happens? So when we have a code to compute, it takes a computation, but whenever we need data from the memory, we need to access the memory, then we have a memory stall cycle. So when the data is exchanged between memory and the processor, then again computation continues. Then whenever memory help is required, then the processor used to stop and wait for the data to come in and write or read, then again. So this was single thread operation. It works with a compute thread, compute cycle, memory cycle alternately. So instead of that, if we could create a two thread processor core, then when one thread is working with a memory, the another thread could be working with a computation. So we can interleave these computation and memory cycles, so that any time if you look at it, either at thread 0 or at thread 1, one computation is going on. So first part thread 0 is computing, second part thread 1 is computing, third part thread 0 is computing, then thread 1, then thread 0, thread 1, thread 0, thread 1. So if you look at it, then the process will never stop, whereas in the previous case the process was coming to an halt whenever a memory access is required. So whenever memory access is required, that time the thread continues to wait for the memory. By that time another thread takes up the next task, continues the work, and when the next thread needs memory access, then the first thread comes back and takes the control and continues. So this way we can see that every slot there is one compute cycle, and hence the computation goes faster. So in all, what is happening here is one CPU's core has two threads, and because of this the process has speed up 2 times. So if we take an example, UltraSpark TI CPU, it has got 8 cores per CPU per chip, and each core can have 4 hardware threads. So 8 cores per chip, and each core can have 4 hardware threads. That means in all, we can think from the outside world perspective that UltraSpark TI, this processor is equivalent to 32 logical processors. That means in parallel it can run 32 processes or 32 threads simultaneously, because there are 8 cores in one chip and 4 hardware threads are there per core. So that makes 32 logical hardware threads in this CPU. So from the outside world it appears as if 32 are being run simultaneously.